it paradise, but I call it home. What more can I ask for? I have all that I long for. Suddenly, all the voices came to sing with me. That you call it beautiful, it's true, but I have one thing to say to you. I believe there is more to what you see. You call it beautiful, it's true, but I have one thing to say to you. I believe that we all should make it known. You call it paradise, but I call it home. I call it home. I call it home. I call it home. Yeah.
My weary heart soars high like an eagle in the sky when I look into your eyes.
The sunset's warm embrace gives delight in many ways, and it comes as no surprise. When I'm down and blue, my heart goes back to this place to start anew.
When I'm with you, I see color in everything they saw as gray. When I'm with you, my tomorrows are brighter than my yesterdays. All the world is fine and bright when I'm with you. It may soft and shine lows, but we may never know the things that lie ahead.
The time may swiftly fly, we may have to say goodbye, but your friendships never end.
When I'm down and blue, my heart goes back to this place to start anew.
When I'm with you, I see color in everything they saw as gray. When I'm with you, my tomorrows are brighter than my yesterdays. All the world is fine and bright when I'm with you.
No one else but you can change a soul like mine.
When I'm down and blue, my heart goes back to this place to start anew. When I'm with you, I see color in everything they saw as gray. When I'm with you, my tomorrows are brighter than my yesterdays. All the world is nice and fine and bright, and everything's alright when I'm with you. When I'm with you, I see color in everything they saw as gray. When I'm with you, my tomorrows are brighter than my yesterday. All the world is nice and fine and bright, and everything is alright. All the world is fine and bright when I'm with you.
When I'm with you.
There's a song deep inside I can't erase. It's all about this amazing place, a home that we all can share. Listen to the music, see the sights to see. We get a very scenic university. VSU in my heart, VSU in my heart. Listen to the music, sing with us a song. VSU in my heart.
There is so much this school has given me, the sunsets and truths beside commodity. Oh, how can I repay?
Listen to the music, sing it cheer, cheer. At the Visayas State University. VSU in my heart, VSU in my heart. Listen to the music, sing with us a song. VSU in my heart.
104.7 KDWA.
It's here at the Visayas.
Alright, good afternoon. Time check is 4:18 or 4:13 in the afternoon. Alright, so kumusta? Happy New Year mga ka-DYDC o mga kaigsuunan nato diha sa kahanginan. Welcome to our program. This is Matsaya. Kauban gihapon ang yung sir sa kahanginan, teacher sa kahanginan. This is Sir Raymond. Karon sa usa ka oras nato pagtulunan karon nato i-discuss no ang ato especially sa ako mga kasyentihan diha karon. Good afternoon sa ako mga students in mathematics in the modern world. This is part of your module. No, this is module 3 lesson 2. So this is 3.2. So for 1 hour we'll be talking about measures of central tendency, position and variation.
Down the road one day, happy people smile along the way, and the sceneries turn on my fantasy.
Alright, so I hope nga inyo ko ba na no until 5 in the afternoon sa to programa karon sa Matsaya. Another topic na po daw, another discussion na po na we'll be discussing another topic. And I hope that this can help you know in answering your assessment, your task, especially for this lesson.
You call it beauty.
Alright, so this is actually a continuation of what we have discussed last time. Okay, if you can still remember, our lesson 3.1 discussed about how to gather and organize our data using the graph and tables. And right now, no, for lesson 3.2, we'll be discussing more on the two measures, the measure of central tendency, position, and variation. Alright, so our learning objectives, no? So we are, after a 1 hour lesson, we'll be able, no, to describe the properties of central tendency, variation, and the shape in numerical data. To calculate descriptive summary measures, for example, to construct and interpret a box and whisker plot, and of course, not to describe the covariance and coefficient of correlation. So before we'll proceed to our main discussion, allow me to give you some of the important definition of terms in our lesson for today that you are going to remember as we go along with our discussion. So the first one there is the central tendency. So unsa man ang central tendency? This is the extent to which all the data values group around a typical or central value. So we have three major categories for the measure of central tendencies. So we have the mean, median, mode, and these three are the most commonly used measures for central tendency, of course. So later on, you will know how to use when and how to use mean, median, and mode. Most especially if you are research inclined, for faculty or for teachers or even for students, these measures are actually very common for presenting data. The second measure is the measure of variation. This is the amount of dispersion or scattering of values. So in this discussion naman, we are going to discuss more on how your data are being scattered in a graph, or unsa ang iya scatter dispersion, ang iya kalagyoon sa data, no? So let's say for example, one data is giving you the characteristics of scattered, no? Scattered ang iyang mga values or dugol ang iyang mga values. Okay, and of course, we have to discuss also the shape, no, the pattern of the distribution of values from the lowest value to the highest value. So yon, so first topic is about how to measure or first measure of central tendency, which is the mean or the arithmetic mean. So the arithmetic mean or just simply mean is the most common measure of central tendency. In our in some references or in common references, no, we term arithmetic mean as the average. Okay, so average meaning all you have to do is to add all of the data, to get the sum of all your observed values, and then you divide that one to the number of observed values. So let's say for example, if you have the data 1, 2, 3, 4, 5, and then you get the average for this or the mean for this. So first step is to get the sum of this data or these values. So let's say for example 1 plus 2 plus 3 plus 4 plus 5, that is equal to 15, and then you divide that one. You make you use 5 as your denominator because there are 5 observed values. Okay, so 15 divided by 5, that's 3. So the average for that is 3. Let's say for example, if I am a teacher, and I have 30 students in my class, right? So if I have 30 students in my class and I have given them 10 item quiz, all right? So and I have to determine what is the mean or how much is the average of their scores. So what I'm going to do is to get the sum or to add all of the scores, right? To add or to get the sum all of the scores of my students, of my 30 students, and then the sum will be divided by 30 because there are 30 observed values. Okay, so yon, that's the mean. Again, so the definition for mean is the average. It is just the sum of the values divided by the number of values. And among these three, measure of central tendency, arithmetic mean or average is very affected by extreme values or what we term as outliers. Meaning, it can also affect your interpretation of data. Okay? So depende siya kung naa kay dali ra man gud siya, it can easily be affected by outliers. Let's say for example, unsa may pasabot aning sir, unsa man ning outliers, unsa ibot pasabot aning outliers. Let's say for example, you have taken a 100 item exam and then the highest is 100 and the lowest is 0. So, upon checking up, if you are going to check or if you are going to get your mean there, probably the data will be affected by these values, by the extreme values or outliers, because your highest is 100 and your lowest naman is 0. And the gap between 0 to 100 is very high, and this can be considered as our extreme value or outliers. Okay, so ing ana ka masala, ing ana ka dali ra maapektuhan ang ato arithmetic mean if you have extreme values. You have high gap for or bigger gap for your lowest and highest value, observed value.
A home that we all can share. Listen to the music, see the sights to see.
Alright, so for the second measure of central tendency, let's proceed to the median. Okay, so ang median is an ordered array. The median is the middle number or the 50% above and 50% below. In other words, the median is mao ni siya ang tunga-tunga, the midpoint, the center of your observed data. So it is not affected by extreme values compared to or unlike sa mean nga dali lang siya maapektuhan sa ato extreme values. But the median cannot be affected or not affected by extreme values. So imo lang first you have to remember that in getting the median, you have to arrange first your observed values or data. You have to arrange your data into ascending order or in an array form, ordered array. let's say for example from lowest to highest. Okay, so it should be from lowest to highest. So let's say for example you have 30 observed data, no, 30 scores from your students. So you have to arrange that one from lowest to highest, and then to get the median, you have just to determine no kung asa ang midpoint or ang tunga-tunga, 50% above and 50% below of from your 30 observed data. Now, how to get naman your median? So we have steps not to follow, and we have also conditions to meet. No, let's say for example, if your sample or if your population or if your observed data is even or odd, then you can also use a different formula in finding no your median no for that case. So on saan man, so here's how to find no or locate the median no in a data. So sa ato central tendency. Alright, so the median of an ordered set of data is located at the n+1 over 2 ranked value. So your n there is the number of observed data. Let's say for example, you have a data of 30 scores no, from your 30 students. So your n there is 30. Alright, so let's say for example, that's 30. So 30 plus 1, that's 31. Divide by 2, that's 15.5. No, that's still no the rank value. Dili pa na, it doesn't mean that is the it doesn't mean that mauna na siya ang median. It's just the rank value or the position, no? Dili pa na siya, imbo mo man na siya i-locate, no? After determining the rank value, you have now no the time to locate that one sa imo data kung asa siya na belong. So let's say for example, if you have 30 students, so your n is 30. Okay, so your n there is 30, and then plus 1, so 31 divided by 2, that's 15.5. Meaning, your median is located between 15 and 16. Now, between 15 and 16. So, unsa may imo-himohon ana, what you are going to do next? So, you have to count, you have to determine what is the value of the 15th rank and the 16th rank. So, let's say for example, imo na siya na-arrange, no? Again, the first step is to arrange your data in an array or ordered array. So, ascending order, so from lowest to highest. So, say for example, after arranging that one from lowest to highest, you found out that the 15th, no, ika-15th, no, nga score is, let's say for example, 10-item quiz, no? 10-item na quiz. So, the 15th score there is 8, no? And the 16th score is 9. So, you have to add these two values, no? So, 8 plus 9 equals 17 divided by 2, that's 8.5. Meaning, your median is 8.5. Okay? So, katong 15.5 is just the rank value. And after determining the rank value, you have to count no sa imo data kung asa dapit ato ang ika 15.5, meaning mao na siya ang gipatong-an ni 15 og ni 16 rank, no? So what you are going to do is to add the value sa imo ika 15th o ika 16th, divide by 2, then that would be the value of your median. So if the number of values is odd, the median is the middle number. So man ako example ganihan, no? If the number of values is even, the median is the average of the two middle numbers. So ganiha sa ako gi-example, 30 ako gihatag nga example as n. So that will become, we know that 30 is even, no? So the average of the two middle numbers. So mo to siya nga 30 plus 1 divided by 2, that's 15.5. So the average of the 15th and 16th in rank. So that is your median. Pero kung ang ato n naman is odd, so there's no need to get the average kay all automatic na siya that the middle position or the middle value would be your median. So for example, your n is 45, no? We know that 45 is an odd number. Okay? So imo lang i-count nga 50% below 45 and 50% above 40% below, 50% below and 50% above the median. So bao na siya ang imo median. So let's say for example, 45 ang imo n. So i-divide na to og 2. Or simply no, 45 45 plus 1, that's 46, divide by 2, that's 23. Meaning, ika-23 nga rank, mauna siya ang imo median. Okay, so mag-ihap na pud ka from 1 to 23rd, no, ika-23rd nga value, that would be your median. So, ingana lang ka-easy, no, to determine or locating your median. Note that n plus 1 is not the value of the median. Again, I will give you an emphasis on this, no, that the n plus 1 is not the value of the median. It is only the position of the median in the rank data. When we say rank data, mauna siyang ako giingon ganiha nga imo na siya i-arrange from lowest to highest. Alright? Alright, so the third measures of central tendency is the mode, no? Triple M ang good ni sila, no? Ang central of tendency, the mean, median, mode. So the mode is the value that occurs most often. So meaning ang pinakadaghan nga nagbalik-balik sa ato data. Unsa ni siya? Kumbaga, ang pinakadaghan nga ato ma-observe, no, or makita sa data. It is not affected by extreme values, the same with median, but different with the mean. If among these three, no, only the mean is easily affected by extreme values. Median and mode are not affected by extreme values. Mode is used for either numerical or categorical data, and there can also be no mode or naapod kay data nga daghan pud siyag mode. Mo nang giterm na to nga multi-mode or multimodal ang data. Okay? Kung usa lang, of course, nasa unique nga mode, no? Let's say for example, in our example here, no, there may be several modes or no mode. So sa ato diagram diha on our screen, no, we can see that 9, no, has the highest number of frequency because it has 3, no? So for 1, only 1. So for 3, we have 1. For 5, we have 2. For 7, we have 1. For 9, we have 3. For 10, we have 1. For 12, we have 2. For 13, 1. And 14, 1. So in determining the mode, all you have to do is to see, no, if asa, no, among these values have the highest number of frequency or has the highest frequency. So we can see that 9 has 3 and it has the highest frequency. So 9 is the mode for this example. For the second diagram naman, since they have the same number of data, no, or frequency, no, for each score, for example, then wala siya mode. Okay? So wala siya mode kay pareha lamang siya. Pero kung for example, ang 12, gibutangan ako another circle here. So meaning 9 and 12 will have the same frequency. No, for 9 and 12 will have the same frequency. If I will add another one circle here for 12, so meaning we have two modes here, 9 and 12, and that is termed as the bimodal. No, bimodal na siya. Duha ang ato mode for that. Okay? So measures of central tendency, which measure to choose? So the mean is generally used unless extreme values or outliers exist. So in most cases, probably in research or in analyzing data or interpreting data or in describing your data, because most cases usually these measures of central tendency are commonly used in descriptive statistics, okay, in describing data. And in most cases, mean is generally used unless you have the presence of extreme values or the outliers in your data. So that's why you have to use the median or the mode, no? Pero in most cases, no, most of the time, in describing your data, mean is generally used. Then the median is often used since the median is not sensitive to extreme values. For example, median home prices may be reported for region. It is less sensitive to outliers. But okay, we have the same we have the same prices for the commodities or goods, no? This is for example in our region, since we are more kanaganing provinces, no? So sa ato place, for example, in Baybay, Probably we have different median for home prices of for these commodities or products or goods that we are going to buy in the market compared to the city, to other regions. Kay mas dako pod ang ila prices nga to compared, no, here probably ing ana, so pwede na siya.
There's a lot of
The measures of central tendency for the mode naman, the value that occurs most often and it is not affected. Ay, nabalik na ni siya, no? Okay. And then for, yeah, so that's it, no, for the central tendency. So again, we have three measures of central tendency: the mean, median, and mode. The mean is just the average. To get the mean, you have to add all the values, divide by the number of the observed value, no, in your data. For the median, imo lang kuhaon ang center, no, nga value for that. Okay? So, imo lang n+1/2, that's only the formula, no, in finding the rank. But in finding the median, you have to first arrange your data from lowest to highest, no, para makuha na to ang rank niya. For mode naman, it's very easy. After arranging it from lowest to highest, makita na to dayon, no, kung what value ang naay highest number of frequency or highest number of value nga na-observe nato. So that's the measure of central tendency.
but I have one thing to say to you.
For kuan na pod sa variation naman, so we have the quartile measures, the standard deviation, and the variance, no, and the IQR, the interquartile range, no. Interquartile range or the IQR is very also very important and useful. Most importantly, if you have outliers, if you have the presence of outliers or extreme values in your data, because IQR can limit, no, the presence of your IQR. I mean, IQR or the interquartile range can limit the presence of your outliers or extreme values in your data. So how it works, later on you will know that one, no? So let's start with the quartile measures. No, so mo aning giingon na to nga Q1, Q2, and Q3. So the first quartile, the Q sub 1, is the value for which 25% of the observations are smaller and 75% are larger. Q sub 2 is the same as the median. So in checking your answer, you have to see to it that the value of your median is equal to the value of your Q sub 2. No? Oo, so the same na sila og value ni median og ni Q sub 2. So 50% are smaller and 50% are larger. So mao na siya ang imo i-take note, no, diha a class nga you have to remember nga oy dapat ang ako Q sub 2 equal siya sa value sa ako median. So mao na ang imo bantayan kay kung dili sila pareha, there's something wrong in your process, there's something wrong in your solution. There might be some mga mistake, no, sa along the way, no, sa imo pag-solve sa problem. And for the Q sub 3, only 25% of the values are greater than the third quartile. Okay? So how to locate, no, using quartiles. So find the quartile by determining the value of the appropriate position in the ranked data. So again, this is only the ranked data. It doesn't mean nga mauna siya ang value automatically. Okay? So ang ato gikuha nga ri is only the rank value. So naa may rank value nga nag-inform na to diha, meaning we have to arrange our data from lowest to highest for us to be able to locate what quartile is your data or your data is, or your data located. Okay? So, mo na siya, dapat you have to arrange your data in ascending or ordered array or from lowest to highest. So, the first quartile position can be determined using the formula n+1/4. Again, ang n is the number of data, no? Imo ipon kung pila ka buok, no, ang imo observed data. So let's say for example, if you have 30 as your n, so 30 plus 1/4, that is the rank value. No, rank value pa lang na siya, dili na siya mauna na ang Q1, Q2 or Q3. Rank value pa lang na siya. Imo pa na siya i-locate sa imo data nga na-arrange nimo. For second quartile, the same formula sa median, that's n+1/2. For third quartile naman, you have 3 quantity n+1/4. So where n is the number of observed values. Okay? So mao ni siya ang ato lang tigamnan, no? These are the three formulas or equations that we are going to familiarize with so that we can get, no, the Q1, Q2, and Q3. So example. So we have here rule number 1. So here are the guidelines, no, that we have to meet, or the conditions that we have to meet before applying, no, our formula. So rule number 1, if the result is a whole number, then the quartile is equal to that rank value. Let's say for example, after using the formula, your rank value there is 8. Answer there is 8, so whole number, no? Meaning, ang ika-8 daw nga value. So imo ipon ang first, second, third, fourth, fifth, sixth, seventh, ika-8. No, kinsa man ang ika-8 nga value sa imo ordered nga data. No, sa katong imo gi-arrange nga data from lowest to highest. Kinsa man ang ika-8 nga position, mao to siya ang imo quartile value. Okay, kana kung whole number. Kung sa rule number 2 naman, if the result is a fraction half, like 2.5, 3.5, 1.5, 5.5, basta na ay 0.5, no, fraction half, then the quartile is equal to the average of the corresponding rank values. Let's say for example, the answer is 3.5, no, 3.5, meaning the quartile value for that is the value or the average of the third and the fourth value. So let's say for example, ang ika-third nga value ngadto imo gihap ang first, second, third, ang ika-tulo nga value na imo nakita is 10. O nya ang ika-upat kay 12. So 10 plus 12, that's 22, divide by 2, 11. Therefore, ang quartile value nimo ana for 3.5 nga rank is 11. Okay, so mao na siya kung fraction half, imo i-add ang, for example, 3.5 ang imo answer, no, sa rank value. So imo i-add ang ika-3, ika-third nga value o ika-fourth nga value, divide by 2, then that would be your quartile value. Kana kung fraction half ang answer. For rule number 3, if the result is neither a whole number or a fractional half, you round the result to the nearest integer and select that rank value. So let's say for example, your answer is 3.67. So you round off or round your answer or round the result to the nearest integer. So unsa may sunod, unsa may duol ni 3.67? Is it 3 or 4? Di ba mas duol siya ni 4? So ato na siya i-round up to 4. Pero if your answer, no, if your answer is 3.33, 3.2, 3.12, 3.1. So imo ra siya i-round, no, i-round ang imo results, round off your answer to its nearest integer, which is 3. So ang ika-third, meaning ang ika-third nga value, that would be your quartile value. Kung 3.67, 3. Basta rounding off nga rule, no? I-round up nimo, i-round off nimo. Then kung sa ang whole number nga answer, then that would be your rank value, and then i-count nimo sa imo values, then that would be your quartile value. Okay, so example, find the first quartile. So sample data in ordered array. So ako na siya gi-arrange, no? So ako na siya gi-arrange daan 11, 12, 13, 16, 16, 17, 18, 21, 22. So pila man ang ato n values here? So pila man? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why our n here is 9. So for q sub 1 is in the n plus 1 over 4. So n plus 1, that's 9 plus 1 divided by 4. So 10 divided by 4, that's 2.5. So half fraction or fraction half siya, no? So since fraction half siya, na-fall siya sa ato rule number 2. No? So meaning, ato i-add ang duha ka values sa ikaduha o ikatulo. So kay 2.5 man siya. So kinsa man ang ato, what is our second value there? That's 12. Our third value is 13. So we have to add 12 plus 13 divide by 2. That's 25 divided by 2. That's 12.5. Meaning 2.5 is the rank value, but the value, no, the value of your first quartile is 12.5 after adding the two values 12 and 13 divided by 2. So meaning, no, the answer for this question, no, the first quartile is equal to 12.5.
Memories bring me closer to
So Q1 and Q3 are measures of non-central location. The Q2 is the median, a measure of central tendency. Okay? So variation, so maulan to siya. So how about if we are the same data, no? Let's have another example. How about if you are going to get Q sub 3, no? So to find Q sub 3, so you have to multiply, no, 3 quantity, and so our n is 9, diba? We have 9 observed values. So 9 plus 1, that's 10, times 3, that's 30. 30 divided by 4, pila man ang 30 divided by 4? Okay, 30 divided by 4, that's 7 point something, no? 7, 28, so 225, 7.5. No, that's 7.5. So kay fraction half man siya, no? Kay 7.5 ba ng ato answer, so fraction half, meaning ang ato rank value is 7.5. So mag-ihap ta sa ika-7 o ika-8. So 1, 2, 3, 4, 5, 6, 7. So ang ato 7th nga value is 18, o yung ato 8th nga value is 21. So 18 plus 21 divided by 2, that's 39, no? 39 divided by 2, that's pila? 19.5, no? 19.5. So therefore our Q sub 3 is 19.5. Okay, so that's about quartiles. Now let's proceed to variation, measures of variation. So variation measures the spread or dispersion of values in data set. So unsa daw kakatag, unsa kadugol, unsa kadikit ang imo mga data, ang mga values sa imo data, unsa kalagyo, no, ang mga scores ingana. So that's why we have the range, no? The range, the interquartile range, the variance, the standard deviation, and the coefficient of variation. So these are the common measures of variation, no? For range, it's very easy, no? So for range, it is just the difference between the highest and the lowest observed value. So let's say, for example, here, in our data here, our highest value is 13, our lowest is 1, so 13 minus 1, we have a range of 12. No, the gap of the highest and the lowest value. Okay, it is the simplest measure of variation. It's just the difference between the largest and the smallest value. Okay, mao na siya ang range. For disadvantages naman of the range, it ignores the way in which data are distributed. So let's say, for example, kaning sa first figure nato, no? So the data there are spread na natay score for 7, 8 until 12. But here sa second figure, no, our data natay 7 na po tay 12. Ngano man iya man gi-ignore? What does it mean that it ignores the way in which data are distributed? If we can observe, they have both presentations have the same range, but they have different data presentation. So both pasabot ana, they have the same lowest 7, 7, the same highest 12, 12, but the presentation of the data or the spread or the unsa pa na siya, no, ang presentation sa ato data is different. Okay? So let's say, for example, ngari walay score ni 8 og ni 9. No, walay score ni 8 og ni 9, pero sa first figure naa. Pero if you are going to get the range, they have the same range, no? 12 minus 7 equals 5. Here, 12 minus 7 equals 5 still, no? So the same sila range pero different ang distribution, kumbaga, no? Distribution sa mga scores. Okay? And it is also sensitive to outliers, no? Ang range is also sensitive to outliers. See, for example, naka-extreme values. No, here, lowest is 1, highest is 120. So 120 minus 1, dako kaayo ang range, no? Extreme kaayo. But here, 1 ang highest 5, so 5 minus 1 is 4. So gamay lang ang iya range. So dili kaayo siya affected siya, no, sa mga outliers or extreme values nato. If you have very low value of the lowest and very high value of your highest. So mao na siya. Now, for the interquartile range naman or the IQR, mo na ako gihong ganiha that if your data has the presence of the outliers or extreme values, then IQR might help you, no, because it might lessen, no, the presence of the outliers or extreme values. Now, problems caused by outliers can be eliminated by using the interquartile range. Although it is not 100% assurance, but at least, no, minimize niya, it can limit the presence of your outliers or extreme values in your data set. So the IQR can eliminate, no, some high and low values and calculate the range from the remaining values. So interquartile range is just equal to the third quartile minus the first quartile. So you have to find first, no, the quartile values, the third and the first. So Q3 minus Q1, then that is your interquartile range. So after getting the interquartile range, so nga rin naka mag-base na pod sa imo data. So ma-eliminate na nato ang ato mga extreme values. Kaya ato naman gi-eliminate ang lowest, no, ang 25% low o 25% high. So nata sa tunga-tunga nagbase. So nga rin makita nato sa to figure. So natay minimum, unya maximum, so 12, unya maximum 70. So nakita nato nga that for example, no, ang first after computing and after finding the values of your quartiles, Q1, Q2, and Q3, you found out that Q1 is equivalent to 30 and your Q3 is 57. No, 57 meaning na akay 25% low, 25% high. So ang ato lang i-consider sa IQR or the interquartile range na ang ari sa middle, no? Sa center between 30 to 57. So the interquartile range would become the value of your quartile number 3 or the third quartile, that's 57, minus the value of the first quartile, which is 30. So our interquartile range here is only 27. No? So na-minimize siya, na-lessen siya, 27 na lang, compared to a simple range which is 70, no? The highest, 70 minus 12, which is pila, mga 50 or 50 plus, no? 58. Diba? So, ingana kalayo ang ato range ana if you are just going to use the range. 70 minus 12, that's 58. Compared to the IQR, 57 minus 30, your range now will become 27. So, diba, na-lessen ang ato extreme value, no? So, mao na ang usa ka gamit, no, sa interquartile range.
There's a lot of opportunities that point me to who I could be.
Alright, so for variance, the variance is the average or the approximately of square deviations of values from the mean. So this is the formula, no? That's the squared of your S. Okay, is equal to the summation of all values squared over, or the square of all values, the difference of all values, or X, no? X bar is the mean. You have to find first the mean. And N is the sample size. The X sub I is the values, no, of your data. Let's say for example the first, second, third, and fourth. Okay, so let's say for example here in our data, katong ato data ganiha. Okay, let's say for example this, no. So kuhaon na to ang mean ani ni 7, 8, 9, 10, 11, 12. Tapos 7 minus the mean, 8 minus the mean, 9 minus the mean, 10 minus the mean, 11 minus the mean, 12 minus the mean. And you have to square each. No, mo na ang buto sabot sa formula diha a. No, kana siya. And then divide that one by n minus 1 if your data has 30 observed values. So 30 minus 1, that's 29. Divide by 29. Okay? So here is the formula, no, for the variance. And for the standard deviation, no, variance is just the square. If you are given the standard deviation, no, kung given na kag standard deviation class, imo lang na siya i-squared, that is the value of your variance. Pero kung given po kag variance, to get the standard deviation, it is just the square root of your variance. Makita na to, ma-observe na to ang formula. Tanawa, kung tanggalon na to ang kaning square root symbol, no, if you are going to eliminate the square root symbol, the same na siya formula sa ato variance. No? Kay si variance is just the squared of your standard deviation. And so, standard deviation is just the root or the square root of your variance. No, kung naay problem nga gitagaan na kag value ni standard deviation, so makuha nimo si variance. If you have already given a problem given nga naa nay variance, so imo lang i-squared, that is the value of your standard deviation. Okay? So measures of standard deviation, so steps, so all you have to do is to follow these steps. So compute the difference between each value and the mean. So you have to compute the mean. Ako yung ganiha. Square each difference, no? So for example, ang first score is 7. Ang mean nato for example lang, no, kay 9. So 7 minus 9, that's 2. Squared nato, that's 4. Okay? And then imo i-continue, no, ang the same process. Add the square differences. Divide this total by n minus 1 to get the sample variance. Take the square root for the sample variance to get the sample standard deviation. Okay? So example. Natay example, no? Natay example here. Okay? So natay data nga 10, 12, 14, 15, 17, 18, 18, and 24. So una, pangitao na to ang pila man sila kabuok. How many are there? Or pila man ang ato observe value? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have there 8 observed values. The mean there is to add all of this data, all of these values, divide by 8. So muna tang mean nato is 16. Okay? So your standard deviation there is 10, kana siya, minus the mean, that is 16. So muna siya, plus 12 minus 16, plus, of course, don't forget the squared, no? Plus 14 minus 16 squared, plus 15 minus 16 squared, and so on, plus 24 minus 16 squared over n minus 1. Our n is 8. So n minus 1, that's 7. So i-total ni nato tanan sa numerator, that is equal to 126. Divide by 7. So approximately, you have a standard deviation of 4.2426. So that's your standard deviation. Unsa ang pagkuha sa variance? Imo lang ni i-squared, no? So nakuha naman nato ang standard deviation, which is equal to 4.24. Kung ato na siya i-squared, 4.2426 squared, that is the equivalent or the value of your variance. Okay? So mo lang na siya, class. So mean there is 15.5. The standard deviation there is 3.38. So data B, data C. So makita na to nga rin, lain-lain silang value ni standard deviation. So si data A naa siya 3.38. Si data B naa siya 0.926. Si data C naa siya 4.570. No? Bota sa butan na gamay gani ang value ni standard deviation, meaning dili kaayo katag ang ato values or ang data. No, makita na to diha, for example in data B, we have only a standard deviation of 0.926, which means ang values nato dili kaayo siya scattered. No, dili siya scattered, meaning dugol lang ang mga scores nato. So makita nato diha nga 14, 15, 16, 17, no? Mo nang gamay lang, no, the lesser the value of your standard deviation, meaning less scattered pod ang values nato sa ato data set. The higher the value of your standard deviation, the scattered pod ang ato data diha. Okay, so paras ani sa data C, no? So naay sa 11 sa 12, tapos lockdown na po siya, tapos na po sa 19 ug 20. Here, scattered to siya, pero naay mga in-between nga mga scores. Okay, so kung ato i-compare, no, mas maayo og data si data B, kay lesser ang iya standard deviation, no? Kay meaning, dili kayo scattered ang data. Okay? So this is the normal, no? The normal graph distribution, no? Small standard deviation and the large standard deviation. Okay, so measures of variation, summary characteristics: the more the data are spread out, the greater the range, the interquartile range, the variance, and the standard deviation. So mana diha, ano? So kung mas spread gani siya, mas kata gani ang ato data, mas dako jud ang range, ang IQR, the variance, o the standard deviation. The more the data are concentrated, the smaller the range, the interquartile range, the variance, and the standard deviation. If the values are all the same, so walay variation, no? Walay variation kay all the same. For example, ang tanang scores kay 15 tanan. Oh, 15. So walay variation. All these measures will be 0. Okay, so wala variation kay di say man sila tanan. None of these measures are ever negative. So dapat positive ni tanan values ni range, ni interquartile range, ni variance o ni standard deviation dapat positive value sila. Positive integer ang answer ani. Okay? And then the coefficient of variation, CV is equal to the standard deviation or over the mean times 100. Okay? So, mana siya ang formula, no? So, for example, you have average price last year, 50. The standard deviation is 5. So, standard deviation is 5 divided by 50 times 100. So, you have 10% coefficient of variation. Okay? So, 5%. So, both stocks have the same standard deviation, but stock B is less variable related to its price. Okay? So, kay 5% lesser man siya compared to 10%. So, meaning, less variable siya relative to its price. Kay dako man siya price, 100 compared niya rin sa 50. Although they have the same deviation, standard deviation, but they have different average price. So, therefore, lesser ang variable or ang stock B, ang deviation ni stock B, no, compared ni stock A. For z-score naman, it is an outlier or extreme value. No, an outlier or extreme value is one that is located away from the center or the mean or the median of the data set. So outliers invalidate conclusions we draw from data. So z-scores are useful in identifying outliers. Okay? So to locate no extreme outliers using z-score, to compute the z-score of data value, subtract the mean and divide by the standard deviation. Okay, so a data value is considered an extreme outlier if its z-score is less than -3 or greater than +3. Okay, so z-score, the formula of z-score is used no to determine if that observed data is either an outlier or dili siya outlier. So after solving this, if the value is lesser than -3 or greater than -3, then that particular value of your data set is an outlier. Okay? The larger the absolute value of the z-score, the farther the data value is from the mean. So this is the formula, no? X is the observed data, X bar is the mean, S is the standard deviation. Okay? So example, suppose the mean score in an achievement test in math is 490 with a standard deviation of 100. Compute the z-score of a test score 620. So your observed value is 620, your mean is 490, then your standard deviation given, standard deviation is 100. Sometimes kung dili gani given ang standard deviation, then you have to find it first. Since na-discuss naman nato unsaon pagkuha sa standard deviation, no? So, 130 divided by 100, so 1.3. Unsa man ang 1.3? Is it greater than 3 or lesser than -3? So, wala, no? Lesser than 3 siya, but greater than -3. Meaning, a score of 623 is 1.3 standard deviations above the mean and would not be considered as an outlier. Okay. So, kana si 620 di ay, dili siya outlier because 1.3 is lesser than +3 but higher or greater than -3. No, kay makonsider man lang nato siya, no? The data value is considered an extreme outlier if its z-score is less than -3 or musobra ni 3. Let's say for example, 3.1, 3.2, 3.3, and so on. So, outlier siya. Kung less than -3, like -3.1, -3.2, -4, -5, negative, and so on. So, outlier po siya. But in our example here, in our example, 1.3, 620 is not an outlier here. Okay? So, 620 is not an outlier here. Okay? So, the data below are the life of the battery of sample of 12 14MP digital cameras. Compute the z-scores of each battery life. Are there any outliers? Okay, so imo lang gamiton. So find first the mean. Unsa ang pagka sa mean? 300 plus 260 plus 180 plus 35 and so on. Divide by 2, 4, 6, 8, 10, 12. 12 ang n. Then find also the standard deviation. Nanamtay formula on how to find the standard deviation. Okay, so this is your practice exercise. Okay, tapos tagsa-tagsaon na to pagkuha si z-score ni 300. No, 300 minus the mean, computed mean. Okay, so, and then, divide by your computed standard deviation. So tanaw na to is 300 na outlier or 260 outlier ba siya or 35 outlier ba siya, no? Ato tan-aon kung asa man ani nga out of these 12 data are outliers. Okay? So that will be your exercise. So, of course, now we have the shape of a distribution. Now we have the left skewed, mean is lesser than the median. Symmetric, equal ang value ni mean ug median. So, kung equal gani ang value ni mean ug ni median, then they are symmetric. Normal distribution siya. Right skewed, kung ang median is lesser than the mean. Okay? So the 5 numbers that describe the spread of the data are the minimum, the first quartile, the median, the third quartile, the maximum. Minimum is just the lowest value or the lowest score. Maximum is the highest value or the highest score. Okay? And then the box and the whisker plot. The same lang ang gamito lang nato ani is ang minimum, highest, then the first quartile, the median, and the third quartile. So makuha na nato ang box and whisker plot. It is the graphical display of the 5 number summary. So, mao ni siya ang whisker plot. The box and the whisker plot. Okay? And yeah, that's all, no, for today. So, data analysis is objective manggod, no? Pitfalls in numerical descriptive measures. Analysis should report the summary measures that best meet the assumptions about the data set. Data interpretation is subjective. Interpretation should be done in fair, neutral, and clear manner. Okay, so that would be all for our discussion for today. Thank you so much.